Hello everyone, welcome to my next tutorial. In this tutorial we are going to simulate an OLED with hexagonal metal grids. Before we start off this tutorial, I want to introduce myself Sahil Verma, application engineer of well-known company Impulse Technology. About the company and their services we have already discussed in my first video. Who has not seen it my previous video, please check out the playlist. We are going to simulate in here a OLED with a hexagonal metal grid. It is related with the first tutorial also, like the same geometry, OLED of 100 mm width and 100 mm height. But in here we are going to improve the conductivity of the electrode, minimize ohmic losses and reduce optical shading. That means OLED panel with more uniform brightness. We can create a metal grid in the electrode, and this type of geometry we are going to create in here with the hexagon that have radius 4 mm and metal grid that's with 0.2 mm. So about the Laoss softwares we have already discussed. We are directly going to simulate this type of structures. Click on the right side of the Laoss and run as an administrator. You can see it is GUI of the Laoss softwares, that means large area organic semiconductor simulation software. About the GUI we have already discussed, but I want to give some short description about their GUI. New projects, like if you want to create new projects you can click on this tab. If you want to load your project, if you want to import your project you can import at the zip forms, and if you want to import directly geometry from the different apps, so you can also use like LibreCAD. In my previous video we have already explained about this. In here we are going to create OLED with hexagonal metal grid. So first we need to click on that new project tab. Now you can see large area and ray tracing you can use for the optical simulations and for the large area. So you can enable that large area, and if you want to set your project path you can use and give in here your project names OLED with hexagonal metal grid to, and click on this OK tabs. Now you can see different geometry forms, DSF geometry forms, like they supported DSF forms, UNV files, predefined geometry, like if you want to create rectangles, and also introduce metal triangle, metal strips, rectangular metal grids and hexagonal metal grids. So you can use that geometry input types. We are going to create one of the hexagonal meter grids, so please select on that tabs, and unit meters, centimeters, mm, so you can use that unit. That parameters you can provide, it totally depend on the users. I am considering one of the examples, so taken width and height as 100 and same for the hexagonal radius at the PPT parts 4 mm and metal width 0.2 mm. Unit we have already considered in here mm, and you can click like so geometry. If you want to create the mesh you can use, and you can break your geometry with the different forms. Geometry have already created in here. Now you can use device IVT tab. Single electrode and couple electrode, it totally depend on the users which type of setting they want for the defaults and for the metals. In here you can see no couplings, ohm, mod grenade, diode model, imported JV curve, imported JVT curve, different formats are available. You can also integrate with the set for simulations, JV and JVT curve types. But in here we are imported JV curves. Same for the metal, import JV curves, and you can also load in here your JV curve. Click on the PC, and it have also present on the FluximAg and Laoss example parts. Like if you click program files, sim, and in here you can see example tabs and IV curves. So IV OLED you need to select. You can see that documents are also available on Laoss tutorials, and click on this, and then you can click apply, and after the click on the graph you can see for the defaults. Same for the metal, you can import IV OLEDs and open, click on the apply and click on the graph for the metals. Unit for the voltage value, if you want to change you can change. For the current density you can change. For the luminance value you can change. If you want to enable that sweeping smoothing you can enable. It totally depends on the users. For the thermal couplings, they're related with the electrical parameters. You can also activate that modules. Thermal coupling, no thermal coupling, heat generation only, and full electrical or thermal coupling. It totally depends on you. Device type, which type of device you have selected in here, like OLED and PV. Simulations, like steady state or AC. According to your selections, tab will active in here. You can see no coupling. Parallel RC, imported curves and set for simulation. We're going to simulate in here the steady state, so you can select that tabs. Now we can move toward the electrode parts. In here you can give the seed resistance value, like you can select 20. Same for the 20. Metal, you can select 0.1 and 0.1. So for the metal seed resistance you can choose 0.1, 0.1. You can see in here the different units are available, but we are considering in here that's units. If you move toward the boundary condition tab, if you select that each first, you can see. But electrical type we have considered voltage. Electrical value automatically considered 0. You need to select for the all voltage like this. For bottoms and for top is only for the boundary condition, volt and millivolts. After this type of settings, you can move toward the shift pad. Totally depend on you type of settings you want to consider in here, like boundary conditions, temperature, electrical current, thermal flux, custom electric, custom thermal. You can see number of the property given in here for the geometry parameters, electrode parameters, electrical coupling loss for the ohm. Researchers are already aware about this type of tabs, so according to that users they can select, but you need to give in here that thermal value, then tab will active, because in here you only variate your value with the fixed range. If you consider set first parameter, so you can also shift that parameters, but in here we are going to shift only potential. You can click boundary conditions. Here you need to shift like each first, each second, each third and each fourth. You can click OK, and you can consider in here shift value, like you can choose 0.9, shift from 0 to 9, and step you can choose. Linear log tabulars parameters are given in here. If you selected the log, so you can choose log. If you selected the tabular, so you can create by your own tables. Load CSV files like this, copy table and paste table. So different tabs are given, but we are considering here the 0 to 9, and click on the OK. Target, like top, bottom or both, according to the shift your result will available on the simulations part. Unit and fit and optimizations, like if you want to extract your parameter with fit IV curves, optimization with the minimize, optimization with maximize, like this you can import, and then you can set in here that targets value like this type of models, free, dependent and variables that you need to select in here. So in here that optimization tab are also given in here, you can choose and you can extract. In future video I will also explain about this optimization tabs. And in the solver, that means which type of algorithm and convergence criteria you want to choose, and then you can select. Like simultaneous solver, it is better methods and take less memory and fast calculations, so therefore we have considered same. Pre-calculate stiffness matrix, yes. And which type of convergence you want to choose, totally depend on the users. And you can also visit last tutorial and manuals why we are choosing, and iterations value you can give. You can see which type of solver, Newton solver with line search, model, Powell doglegs, and path continuation geometry have completed, device IVT settings are completed, electrode value have completed, boundary conditions have completed, shift setting if you want to set fit and optimizations completed, and load project, save so geometry, run missing. So different tabs are given. Projects. Now you can click on the run button, so see one by one each of the results, like top ohmic losses diagrams, bottom ohmic losses diagrams, source power diagram. So at 0 to 9 value and that the fixed ranges, you can see one by one each of the results. For the 2 volts, potential applied on band reach, each first, each second, each third, each fourth on top electrode 2 volts. So one by one you can see like this whole of the results. So now I'm going to end here my tutorials. If anybody have query related to this tutorial, please ask in the comment box, and you can also book demo in the websites impulsetechnology.in, and the last site my emails are also available, so you can directly mail us. And who has not seen it my previous video, please check out the both software video have available on the Impulse Technology YouTube channel. Thank you very much.